To get started with programmable virtual circuits, go to tinkercad.com. Once you're there, you're going to be tempted to click sign up. Don't do that. Click sign in. Then click sign in using social providers. We are going to sign in using our school Google account. Type in your username just like you normally do to get onto the computers at school, followed by apps.matsuk12.us. Put in the same password that you normally use to log into your computer. And then when you get to this screen, you're going to have to allow this 123dapp.com to manage your contacts if we want to use it. Go ahead and click allow. And then once you get to this screen, yours will look a little different than mine. In the upper left corner, you should see an icon that looks something like this. Go ahead and click on it. And when you do, then you should see a screen that looks similar to this. Click on Circuits, and then Create New Circuit. Once you do that, you'll come to a screen that looks like this. This is where we're going to actually create our virtual circuit. There's a button up here for opening and closing the components drawer, and you can drag components into your circuit like so. For now, go ahead and close that, and we are actually going to click back on this Tinkercad icon in the upper left corner. And then we are going to click on properties for this thing we just created, and we're going to change the name to Stoplight. That's enough for now. I'm going to save the changes, and now I can open it back up, and let's see here. I'm going to click on Tinker this. And now I can get back to working on my virtual circuit and eventually programming it. The rest of the video tutorial you will be watching was created using a website called 123D Circuits, which eventually moved all their stuff over to Tinkercad here. So you'll see some slight differences between what you're looking at right now and the rest of the video tutorial, but it's close enough that you should not have any problems following along with that slightly older portion of the tutorial. If you have any questions, just ask. A resistor. And we can add some batteries. I'm going to pick a different type of battery here. One of the differences you'll notice between circuits.io and Tinkercad is that when you go to search for a battery, the only option you're going to see for an AA battery is a single cell. You don't see the double, the triple, or the quadruple. But this single cell will still work for us. We just need to drag it over to this designer area here and then switch the count to double. I'm going to rotate it to make the wiring a little bit easier as well. And you can see right here it says positive, so we want to connect this positive terminal to that part of the diode, the anode, and then connect the negative side to what was connected to the cathode up here, but now it's going to go through a resistor. If I connected this correctly, when I go ahead and start the simulation, I should see the LED light up a little bit. If I click on the resistor and change its resistance from 1000 ohms or 1 kilo ohm, 1000 ohms to 100 ohms, then it should light a little brighter. If I lower the value too much, then it gets damaged, it burns up. So I'm going to put it back to 100 ohms here, and just see that it's shining properly again. At this point, I encourage you to take some time and grab some other LEDs, and you can change their colors. Have some fun with this. Set up a few and get creative. Once you've had enough fun with setting up LEDs, let's go ahead and program them. I'm going to get rid of the battery pack here, and I'm going to add what's called an Arduino to our circuit. Right here, I'm going to make sure that the Arduino connects this ground pin to the resistor here. And then I'm going to connect the other leg to pin 13. Now, most Arduinos have an onboard LED, an onboard light emitting diode. That's what this is, and that's actually what this represents. It's just a much smaller one. Most Arduinos have those connected to pin 13. It's a way of being able to use it as feedback or some sort of indication that your program is running and whatnot. Now that it's time to introduce the code editor, I'm going to interrupt the tutorial with this update. When you click on code, you will see some options. You can program with blocks, you can program with blocks and text, or you can program with text. Click on text. You will get a warning that pops up that says, "Are you sure?" Are you sure you want to close the blocks editor? Any blocks you currently have will be lost. The code in the text editor will remain and become editable. That is exactly what we want to do. So click continue. This is what Arduino C looks like. This is what we're going to use to program this in this tutorial and all of the following tutorials. By programming in Arduino C, we have the ability to do much more in easier ways than we could possibly do with blocks. In fact, some things you cannot do with blocks. There is one other difference you will notice between the rest of this tutorial and the code you see here, and that is this code it doesn't look quite the same, and that's because when the website was upgraded from circuits.io to Tinkercad, they actually downgraded the example code, which I find a little bit annoying because the old code was actually better. Right now, we're going to go ahead and modify this code so that it matches the old code. To do that, I click right up here at the very beginning, right before the V in void, and then hit enter twice. That will give me some room to work above here, and I'm going to create a variable. But instead of using var to create a variable like you would with JavaScript, we have to be more specific when we program an Arduino. We have to tell it what type of variable we're going to program. So I am going to create a variable that is an int, an integer type variable, and I'm going to call it LED. And I will set it equal to 13, and I will end this line here with a semicolon. The reason I have chosen 13 is because this LED is connected to pin 13. Now that I've created this variable, I'm going to use it. So right here where I see a 13, instead of 13 in the pin mode, I'm going to put LED. I will do the same down here with the digital write commands. And the reason I like this approach more is twofold. First, I like that the code is now more readable. When I look at this command, I can see that I'm setting the pin mode for an LED, not for a buzzer, not for a motor, for an LED. It's very clear. And the same thing goes for the digital write commands. I'm setting this LED high, I'm turning it on, and then I'm setting it low. if I had a more complicated circuit, it might be difficult for me to ascertain what is connected to pin 13, and then I'd have to look at my circuit to figure it out. But the way it is right now, I can almost just read it. The second reason I like this is because it makes my code easier to maintain. Suppose, for example, that I changed the way this LED was connected to the Arduino. Instead of being pin 13, it was connected to pin 12. Well, before, when I had uh, 13 hard-coded into my program in 3 different spots, I would have had to change it in 3 different spots. But now I can just change it in one spot and it will work. I'm going to set this back to 13 so that it matches the rest of the tutorial. And I'm also going to mention that one of the other differences between the code you're going to see in just a minute or two and what you're looking at now is comments. The code used to have a lot of comments in it. So for example, the first line went something like pin 13 has an LED connected on most Arduino boards. That would be this LED right here. There was one more line that said give it a name, something like that. You will see more comments interspersed throughout the code in the rest of this tutorial, but because comments are not compiled by the compiler and actually turn into ones and zeros that run on the Arduino, you can ignore them as far as copying them into your code, but it is good to read them because they are notes that they're there for a reason, and it's to help you understand how the program works. The last thing I need to mention before I return you to the old tutorial is that you do not want to click on this box again. If you click this and switch it back to blocks, enabling the blocks editor will clear any code you have in the text editor. Are you sure you want to continue? Here we're going to hit cancel because we definitely don't want to do that. You're going to put a lot of time and effort into the code you have here, and if you switch back to blocks, you will actually lose all of your work. So keep it on text. This is a variable. Think of a variable as a box. What's the label on the box? The label on the box is LED. What's inside the box? What's inside the box is the number 13. Down here, we have the setup routine. There's a setup and there's a loop in all Arduino programs. The setup here is what we use to determine how we're going to set up our Arduino, what's hooked up to it. And so in the setup only runs once. Here we're stating that the pin mode for LED, which if we look back up here, really just means 13, pin 13 right here, which is connected to this green LED, we're setting that to an output. So we're sending information out to this LED. Over here, I'm going to write to that LED high. That basically turns it on. And then I'm going to delay for 1000 milliseconds or 1 second. And then I'm going to write to that LED, pin 13, low, which turns it off. And I'm going to do that again for 1000 milliseconds or 1 second. Because this is in a loop, this little bit of code will just go over and over and over. I'm going to go ahead and start the simulation. And here you can see that the onboard LED is blinking and the LED that we connected to the Arduino is blinking. Now I'm going to modify the program just slightly to make it a little bit more understandable. I'm going to say the green LED, and I'm going to do that down here. And then I have to do that in these last 2 spots down here. Alright, now I'm going to start the simulation again just to make sure that all of the changes I've made are working. And indeed they are. So I've changed the variable name here, and since I changed it here, I had to change how I refer to it here, here, and here. Now I'm going to add another LED. This time, I want this LED to be yellow. I need to connect it again to ground. And this time I'm going to connect the other end to 12. So the high voltage side of this LED is pin 12 if I set it high, and the low voltage side is always here, the ground. Now I'm going to go ahead and change the code. I'm going to add int yellow LED, and this time it's going to be connected to pin 12. Then I have to set that pin to be an output, and then down here what I want to do is make the yellow LED alternate with the green LED. So when the green LED is on, I want the yellow one off. So I'm going to say digital right yellow LED low, and down here I'm going to say digital right yellow LED high. Let's see if this code works. And here you can see the two LEDs are alternating. On your own now, I would like you to add a third LED, attach it to pin 11, and then modify the code as necessary to get it so that it blinks from green to yellow to red, just like a stop sign or a stoplight.